there are tables and there are tables, okay? Basically, I don't call it a table unless it's actually formal. So if you have a chart with information, but it doesn't have all of the elements, then I don't really call it a table. And in science writing, it's important that you organize your tables in the correct way. And you can take some liberties with that, but you need to first know what the basic rules of understanding are about tables. All right, and that's what we're going to deal with right now. It's what the actual rules are supposed to be, or what the original rules were for tables whenever you publish something in the sciences. So formal tables must have a table number. Table numbers look like this. It says table 1. Now you include that word, table. Capitalize the word table, followed by the number and a period. Now if the first table in the document is if you're looking at the first table in the document, it should be table 1. If it's a second table or a third table, those are numbered sequentially. Okay, table 1 is followed by table 2, table 3, and so forth. Okay, does that make sense? I mean, that seems pretty simple, right? And then after the table number, and they have to be capitalized, the number followed by a period. So this is what it would look like. Here, if you look at the top, there says table 1. Table 1, the acceleration of an object compared to the force applied to it. Okay. Now, table 1, there's your table number. Okay, and then we're going to move on to other things here in a minute. This is what a table number looks like in a formal table. And table 2 is followed by table 3 and so forth. Then you have to follow that table number with a table description. A table description tells the reader what's in the table and why the information in the table is important. Okay, so it's not enough to say it's important because Mr. Tedder says so. Right? You got to be a little more, thoughtful than that. All right, why do we need to know this information? Okay, if it's the information that was collected in the lab, you need to tell me about the lab a little bit so I have an understanding of where this information comes from and what it's going to be used for, why it's important. You have to make a judgment here about the most important, the most significant thing about this table, and make sure you include that in your table description. It should be 1 or 2 sentences. 3 sentences kind of overkill usually, but sometimes it may require 3 sentences. Okay, but you don't want to overdo it. All right, try to keep it simple, but be thorough, and that's kind of the balance in the sciences: being simple but being thorough. Okay. So this is what a table description looks like. In this case, this table is about physics. It says the acceleration of an object compared to the force applied to it. Okay? It explains what's in the table, calculations of force and acceleration, and it explains why the information is important, the comparison of force to acceleration. So in this case, it's important that you know how they are related. All right? Table numbers and table descriptions are placed immediately above the top of the table. There's no space between the table label and the top of the table. Okay? Together, the table number and description make up what we call the table label. Okay? Try to say that 10 times without getting yourself all tongue-tied. Table label. You guys don't laugh at anything, do you? My first period, my third period, they giggle at stuff. You guys, man, come on, loosen up a little bit. All right. Anyway, table labels should be single-spaced. All right? You don't double space it. If the rest of your document is double spaced, and usually when you type up a report, you double space it. But the table label should not be double spaced. Okay, if you need some help with that, come and see me. I'll help you with it. All right? All right. Do I need to hold that up there for you a second? Are you okay? Now, and there is a YouTube video, by the way, that already covers all this, but I'm also thinking about probably putting this on there too. But there's a YouTube video that takes all this, runs really fast. So use that, okay? Go back and look at that whenever you're putting together a table or a graph, and make sure you've met all the requirements, okay? Because you don't want to lose points over something that's fairly simple. This is pretty much, check this off and get it right, check this off and get it right. If you do all that, you're going to get all the points for tables and graphs, okay? All right. Then column labels. Column labels describe what observations, including measurements, or what calculated numbers are in that column. That column of, we call those cells. Didn't used to call them cells, but with the advent of spreadsheets, we now call them cells. Or I don't recall them ever being called cells when I was doing tables before computers. Yes, I'm that old. Okay, I was on a first name basis with the Tyrannosaurus Rex. No, not really. Okay. Column labels include units of measurement in parentheses. So the units of measurement are not going to go in the data cells. where the numbers go, you don't put the units of measurement. The units of measurement are going to go in those column labels. Okay? Okay. Now, column labels are in the first cell at the top of a column of data. Most of the time, you have column labels and you don't have row labels, but there may be times when row labels are also appropriate. Okay, so you can see that I've got a description of what's in the column, and then I also have units of measurement in parentheses. Okay, in the case of acceleration, you've got actually 2 units of measurement in the form of a fraction, meters per second squared. Now, sometimes those column labels require more description than that. This is a one-word description. Most of the time, you have more than one word. Okay, you have I don't know, 5 or 6 words, or 8 or 10 words, or something. But you've got more than one word to describe what's in that column. Okay. The description of the data in the column is, in this case, acceleration and force. The units of measurement are in parentheses. And then we have the data cells. Data cells have the actual observations, including measurements, and calculated answers. Data cells with measurement and calculated answers should not have units of measurement. So the units of measurement only appear in the column labels, not in the data cells where you've got the measurements themselves. Now, that didn't used to be a requirement, but with spreadsheets, if you have both numbers and units of measurement in a data cell, you can't have your spreadsheet automatically create a graph for you, and you want to be able to do that. So now the requirement is that only numbers go in the data cells. Now, sometimes you have qualitative observations in a table. Is there anybody that doesn't understand the difference between qualitative and quantitative? That was something you're supposed to learn in physical science. If you don't, raise your hand now. Remember, it's important to understand your own ignorance, right? We talked about that already? Okay, everybody understands. I'm assuming you do. So if you have a qualitative observation like color, okay, like some smell or something else, well, obviously that's not going to have a unit of measurement, okay? But anything you measure or anything you calculate will have numbers associated with it, and you don't put the units of measurement in the data cell. You put those in the column label. Okay, so data cells are placed under the column labels. All right, usually in order, but they don't have to be in order. Okay, sometimes they're not. That's okay. It kind of makes more sense, especially if you're publishing this and you're putting it in some kind of write-up, because it makes more sense to the person looking at it when things seem to be in some kind of order. Okay. Notice the data cells have numbers but do not have the units of measurement. Okay, notice the units of measurement are in the column label. Okay. All right. So here's the graph. Now we're going to be using formal graphs in this class. All right. So that was formal tables. That's the basics of a formal table. In a formal graph, there's certain things you have to have as well. Okay. Notice the title at the top. The title should be centered above that graph. Okay. Now, titles need to clearly indicate the effect the independent variable has on the dependent variable, if there is a independent variable. There are sometimes some graphs for which you really don't have independent variables because one thing is not causing the other. But if you have an independent variable, and in most labs we will have an independent variable if we're going to be doing a graph, that's the purpose for doing a graph, then you're going to have your independent variable on the horizontal axis. We often call that the x-axis. The independent variable goes on the bottom axis, okay? The dependent variable goes on the vertical axis, which very often students call that the y-axis, because you're so used to using x's and y's in geometry and algebra, okay? So when you write your title, you want to write your title in a way that says this is how the independent variable affects the dependent variable, okay? This is how the independent variable affects the dependent variable. That's the basics of a good hypothesis as well. So these are very much in parallel. Okay? A good hypothesis will state if I do something, that something being the independent variable. Then I expect something else to happen, that something else is the dependent variable. Okay? So the independent variable is what you manipulate, and sometimes in some classes in earlier grades you might have called that the manipulated variable. Okay? The manipulated variable is the one that you change, but it's the independent variable. Okay? It kind of stands alone. And the manipulated variable then affects the what's it called? We've used manipulated and responding variable. That's what it is. Okay, so you manipulate one variable, that's the independent variable. That changes the responding variable. That's your dependent variable. So the dependent variable always depends on the independent variable. Does that make sense? Your independent variable goes on X. Dependent variable goes on Y. Now, sometimes you won't see it that way, but that's really the standard. Okay, so when you do it for me, I expect your independent variable to be on X, your dependent variable to be on Y. Okay, and so your title should reflect that. It should say, this is how the independent variable affected the dependent variable, or some variation of that. Now, the sort of general form is the effect of, and you put in what your independent variable is, on the whatever the dependent variable is. Okay, that's the general form of a title for a graph. The effect of independent variable, plug in independent variable right there, on the, and plug in the dependent variable. Does that make sense? Now, if you word it slightly differently, that's still clear in how the independent variable is affecting the independent variable. That's probably okay. But if you want a good form, where you can almost always be sure you're going to get all the points for it, the effect of the independent variable on the dependent variable. Does that make sense? It's kind of a real simple way to do it, and it'll work from now on probably. Okay, there may be some changes when you get into something more complex in science, and that's okay. All right, only dot graphs or scatter graphs are acceptable in this class. In most science research, and in particular in most chemistry research, only dot graphs are acceptable. Now, you get into higher levels of chemistry, and you'll find that sometimes they'll have two independent variables on the same graph. Okay, we're not going to do that. We're going to try to stay simple right now. Okay, if you're taking the ACT test, that science section is based an awful lot on the stuff you read in graphs and how to understand what a graph tells you and how to use it. Okay, so if you're planning to take the ACT, you want to really, get a good grasp on what we're doing with these tables. These graphs, all right? Because what we're doing is essentially what you're learning to do when you're going to be asked to do that ACT test. Okay, the science section anyway. You'll find that an awful lot in there. And so one lab that I often don't do until much later in the year, I'll probably schedule a little bit earlier in the year for you guys because it's much more the kind of things that you're going to see. How many of you are going to be taking the ACT this year? Okay, I'll try to take that we'll do one lab a little bit earlier than we normally do. It'll fit in two different places. So I can do it in the earlier part so you can see this graph and see this lab and how we use that graph before you take the ACT test. Okay? All right. So formal graphs must have titles. The title should have the following form. We just talked about this. The dependence of your dependent variable on your independent variable. Okay? The title should be centered above the graph. So just like we see it there. This is what the formal graph should look like. This is the title written in the form where the independent variable is mentioned first and the dependent variable is mentioned second. Okay, so that's where you're going to put it. That's the way it looks in general. Okay, and then they must have axes labels. You've probably seen these before. We just need to make sure that you're doing all the little pieces that have to be there. An axis label must include a description of the measurements or calculations being plotted on that axis or number line. Basically, a graph of this type has two number lines, one horizontal, one vertical. Okay? And so you have to label that number line to indicate what is going on that number line. What measurements are calculated, what measurements or calculations are being plotted there. Okay? And the units of measurement for those measurements or calculated answers must be there. And again, they have to be in parentheses. Okay? Units of measurement for those measurements or calculated answers must be there. If you've got more than one unit of measurement, you have to show how they're related. They're multiplied or divided or something. Okay? You'll get a chance to see that and use it a lot. So just make sure you're aware of the basic details. some of you to finish writing what you want to write. All right. Notice the axes labels explain what measurements or calculated answers are being plotted on the axis, and they also include those units of measurement there and there. Now again, this is a simplified graph. We don't have more than one word here in the axis label. Sometimes you have to have 2 or 3 or 4 or 5 words, okay? So this is just simplified to kind of keep it straightforward for you, at least as an initial introduction to this. All right. Now, there are some kinds of graphs where you use, let's see, like, I'm trying to think what they're called, logarithmic scales. Okay, we're not going to be using any logarithmic scales in here except when we get to pH. We'll talk about that when the time comes. It doesn't really look like it's a logarithmic scale, but it is. For most of the graphs we're going to do in here, up until very nearly the end of the semester, you always have numbers that go in order, and even logarithmic scales are in order. It's just in truth they really aren't, but we'll talk about that when the time comes. Make sure that your axes are like number lines, where those spaces between numbers are evenly spaced. Okay, it might be an even space between 0 and 10 or 0 and 25 and not 0 to 1, but if it's 0 to 10 is one spacing, the next spacing has to be 10 to 20. The next one has to be 20 to 30. You can't jump around with numbers. Okay, I've seen students do that. Probably wouldn't happen in this class, but I've seen it happen before. Okay, so notice the axes labels here. The axes are labeled, number lines are labeled evenly. Okay, so on the vertical axis here, we've got 0 here and 2 here and 4 here, and that's going up in 2s. And every time we have got another major tick mark, we've got a doubling, or I'm sorry, adding 2 more to it. And on the horizontal axis, going up in 5s. And it might go up in different graduations or whatever. The key thing is that you want to arrange these number lines so that your data is spread out across this graph as far as you can get it, so you can see the pattern. You don't want your data bunched up down in a little tiny corner down here. Okay, you want to spread it out. So if you have a graph in a lab and the data is kind of scrunched up somewhere, or it looks like a flat line or a perfectly vertical line, then you need to spread out your number lines. Okay, and I'll show you how to do that, but you need to spread out those number lines, or spread them out so that you can see if there's a pattern there. Until that number line is spread out far enough and you can see the pattern, then you haven't done all the work you need to do. And fortunately with computers, it's a fairly easy thing to do. Okay, you don't have to plan ahead. You can gather all your data and just tell your computer to do it for you if you know what you're doing. Okay? All right. Notice how the graph data is arranged so the graph is filled and not bunched up in a corner. So figure labels then. Now in tables you had table labels. With graphs you have figure labels. Okay? Figure labels go under the graph where table labels went above the table. Okay? They go under the graph, not above it. Figure labels go under, table labels go above. Now figure labels aren't just used for graphs. They're used for any photographs and they're used for any illustrations. Okay? So a graph is an illustration. Okay? But because it is a figure, then you're going to put that figure underneath and you're going to number it the same way you did with tables. You have figure 1, figure 2, and so forth. These are also single spaced, as was the table label. Figure labels include a number, like table numbers. Figure labels have a description as well, just like tables, except figure labels go a step further. Table labels had to say what was in the table and why it was important. Figure labels also have to explain what's in the graph and why it's important, but it has to go further and say what the analysis is. What analysis can be determined from that graph. The analysis is explaining the pattern. Okay? You're explaining, much like the title, you're explaining how the independent variable is affecting the dependent variable. What is the pattern? Is it a direct variation? Is it an inverse variation? There are lots of other descriptions, but those are the two major ones you need to know about in this class. Okay? In this class, you have to know what direct and inverse are indirect R. Okay? All right. So in this figure label I put at the bottom of this graph, I say figure 1 period. That's what's required. It's the first table in this document. The figure description should explain to the reader what the data shows and the analysis shows. Okay, so I've just given you an explanation down here, instead of actually having a figure label that explains what's in there and why it's important, or the analysis. It's your responsibility to do that. What's in the graph, why it's important, and what is the pattern. So what kind of pattern do we have here? What is the dependent variable doing as the dependent variable changes? It's increasing. As well, that's really kind of incomplete if all you say is increasing. As the independent variable increases, so does the dependent variable. You can say it that way. Okay? And increasing, and it's a direct relationship here. Okay? Because it makes what is very close to a straight line. Now in nature, when you are gathering data, you almost never get data that shows a perfectly straight line. Notice these data points are not directly on a straight line. Okay? But the straight line is implied because it pretty much comes to a straight line. Does that make sense? And so what this is, this straight line here, is not connect the dots. It's a best fit line. Okay? How many of you done best fit lines before? Okay. So in this class, that's what we're going to do. Do not draw connect the dot lines, okay? Unless it just happens to be, you're lucky enough to have a perfectly straight line or a perfect curve or something, okay? You're going to do a best fit line or curve, okay? And if it's a curve, you have to give me what you think is the best fit curve. Now the computers will do it for you mathematically. And this is actually mathematically generated here on this illustration on the screen. So it's actually, the computer does it for you and mathematically works it all out so that there's no real guesswork here. And if you were to take a statistics class where you had to do graphs, you'd figure out what the math is to figure out how these are generated. You might do that if you're doing a higher level statistics class. How many of you taken statistics where you've done graphs before? Have you done graphs in there?
Well, we haven't done anything yet.
Okay. You've been working on it, so you're working there, okay? And maybe they'll just introduce you to it because the math is kind of complex, okay? And with computers, we don't have to do it out, with slide rules anymore. We can use the computer to do it. We don't have to even rely on our calculators anymore, which is kind of great in a way, but because it gets you faster to what you're trying to get to, but at the same time, it also kind of removes you from the process so that it makes it a little harder for students to understand if there are errors, you can recognize them, okay? When is it not a reasonable result? Anyway, all right, remember you got to record all your digits when you're using a digital measuring device like this balance on the left, and you got to estimate your last digit when using a graduated cylinder, okay? And so we got to take care of those significant digits. And what I'm showing you here, this is not a graph. Okay, what's missing? I mean, not a table. What's missing from this to make it a table? What should we be doing here? We don't have a table number. Okay. What else are we missing? Yeah, there's units of measurement in the data in the data cells. We can't do that in a formal graph. Okay. Where should those units of measurement go? In a column label. Now, see, this might be perfectly okay to put in your lab notebook. In fact, I don't expect you to have formal tables in a lab notebook. You're just collecting your data in the lab notebook. But when you publish it, then you want to have it in a formal table form. Okay? Does all that make sense? All right, good. So if you go to the YouTube page for this class and go to playlists, you can search through here and you can probably find some stuff that deals with things like that, like measurements. There may be even maybe a table and graphs playlist. I can't recall. Let's see if we can find something. Tables and graphs. There you go. Okay. And there's a couple of table and graph videos here for you. Okay. And this is the one I was talking about earlier right here. I'm not going to play it for you right now. But if you click there, that's going to go through all the requirements for a formal table and graph in a really fast format. Okay? Got that? And so before you do any formal table and graphs in here, play that out. Okay, just watch it. It's about a 10-minute video. It'll help you make sure you get all the little pieces you need. Okay? Any questions about tables and graphs? All right, everybody good? All right.